or you could perhaps conceivably be working in a larger algorithmic context. Perhaps such techniques might be useful to you too. Have you given that any kind of thought?
The problem with metaprogramming is that you still need a model for the CPU that you target. And they have the same issue. They don't have to touch the actual assembly code, but they have to touch the generator, which might be even worse. So the question is, do you really gain something? And I don't know that. So I looked at metaprogramming in a different context. So I haven't looked at it at all for arithmetic. But it might be worthwhile. So you could argue that this libtom crypt ultra unrolled thing is some kind of metaprogramming, because he obviously generated the code for that. So, but it's worth it apparently if you look at the numbers, but I haven't done it myself.
Have you checked the stability of the timing of the assembly code?
Yeah, this is like 10, 11 loops and taking the lowest one.
No, I'm more referring to guessing the arguments from the timing of the cryptography.
Oh, I took the same number, a fixed number for all of the benchmarks. Everyone is operating on the same data, so there's no...
One of the critical questions you might remember it for a year or so ago about cache mismatching in hyperthreading, where you can start estimating the private keys when you snoop the cache on the second CPU in a hyperthreaded system, which resulted in some changes in the assembly, for example, in OpenSSL. Have you checked something like that so far?
So supposedly Montgomery multiplication helps against the sniffing attack, but I haven't looked at it yet.
Okay.
So that's what I read. I don't quite understand why it would, but...
Magic.
Yeah, well...
Maybe you SMS somewhere or an extension back to bridge address. And maybe that's...
Okay, thanks for your attention.